The A330-200 has fuel tanks located in the wings, in the wing center box, and in the trimmable horizontal stabilizer THS. The trim tank is located in the trimmable horizontal stabilizer. The inner tanks are located in the wings. The outer tanks are located in the wings. The center tank is located in the wing center box. Note: each inner tank is divided into two parts. The division is fitted with a split valve, which is normally open. The total usable fuel quantity is approximately 109,000 kilograms, standard density. Each inner tank has a collector cell, which contains the two engine feed pumps. The two collector cells are always kept full, 1,000 kilograms, in order to provide fuel reserve for the pumps and protection against fuel flow interruption to the engines by negative acceleration. A standby engine feed pump is fitted to each inner tank outside of the collector cells. Two outer tank transfer valves allow fuel to transfer from the outer to the inner tanks. Each inner tank normally feeds its respective engine with the two engine feed pumps. Two engine low-pressure valves are installed to cut off fuel to the engines. The standby engine feed pumps can also feed the engines. The system operates automatically if there is a fault in at least one of the related engine feed pumps. A cross-feed valve is fitted in order to either connect or isolate the left and right-hand wing tanks. The center tank also contains two fuel pumps to transfer fuel from the center to the inner tanks. A trim tank isolation valve and a trim tank inlet valve allow fuel to transfer between the trim tank and the inner or center tanks. Note: only one valve symbol on ECAM fuel system represents the two valves. The fuel system also feeds the APU. A low-pressure valve is fitted to cut off fuel to the APU. This represents the basic fuel system. We will now see how this information is presented to the pilots in the cockpit. Click on the schematic to display the ECAM fuel page. One can see that all the previously mentioned components are displayed on ECAM. Let's briefly review the basic fuel system components by using the ECAM fuel system page. The trim tank in the trimmable horizontal stabilizer, the inner tanks in the wings, the outer tanks in the wings, the center tank in wing center box, fuselage. The engine feed pumps, the standby engine feed pumps, and the center tank pumps. The engine low-pressure valves, the cross-feed valve, the APU low-pressure valve, the trim tank isolation valve, and the trim tank inlet valve, represented by only one valve symbol. For clarity, we have left out some indications. Click on the ECAM page to display them. These indications are trim tank fuel quantity, outer tank fuel quantity, inner tank fuel quantity, collector cell fuel quantity, center tank fuel quantity. Engine fuel used quantity, total fuel used quantity, fuel on board FOB, fuel temperature in the associated tank. Note, fuel temperature is not indicated for the right outer tank. The fuel panel is located on the overhead panel. Another fuel panel is located on the overhead panel and contains the inner tank split, and the jettison push buttons. The inner tank split push buttons enable the inner tanks to be divided into two parts through an associated split valve. Note, the inner tank split valves are not represented on the ECAM fuel system page. Each engine feed pump and center tank pump is controlled by its associated push-button switch on the cockpit fuel system panel. Each standby engine feed pump is controlled respectively by its respective push-button switch on the cockpit fuel system panel. The fuel system panel located wing crossfeed push-button switch enables the left and right-hand wing tanks to be connected or isolated. Note, the crossfeed valve automatically opens in emergency electrical configuration. The trim tank feed selector controls the operation of the trim tank isolation valve. The trim tank mode push-button switch and the outer tank transfer push-button switch enable fuel transfer. You will operate all these controls and see the associated indications in more detail in the normal and abnormal operation modules. During the walk-around, you must check several items which are part of the fuel system. These items are not major components, but a check of their condition is very important. Fuel can be measured manually by the magnetic fuel level indicators located in each fuel tank. We are looking at a magnetic fuel level indicator in the right inner tank. It should be flush with the aircraft surface. We are looking at the water drain valve in the right inner tank. Each tank has a water drain valve. You should check that there is no water leaking from the valve. If there is a leak, call maintenance. A refuel panel is located on the fuselage beneath the right-hand wing. A second and/or third panel is installed close to the refuel couplings. Two refuel couplings are installed under the wings. These couplings allow refueling from both the right and left sides of the aircraft. Note, when both side couplings are used, refueling time is approximately 33 minutes for all tanks. A surge tank is connected to the outer tank in each wing tip and on the right-hand side of the trim tank. These small tanks protect the system against overpressure and thermal expansion. You cannot monitor or control surge tanks from the cockpit. The surge tank inlet should be clear of any blockage. There is also a shroud drain mast. You should check that there is no fuel leaking from the mast. The items related to the fuel system during the walk-around are complete. We will now discuss items related to the fuel system that you will encounter during cockpit preparation. To better illustrate what occurs in the fuel system, select the ECAM fuel page using the ECAM control panel. No, press the Fuel key. With the pumps in the off position, observe the symbology on the ECAM. The pumps are cross-line amber. During cockpit preparation, all white lights in the cockpit must be extinguished. Switch on the left tank pump 1 and observe the ECAM indications. The left tank pump 1 on the ECAM fuel page is inline green, indicating that the pump is running. Continue by switching on the left tank pump 2. The left tank pump 2 is now also running. Click on the forward arrow to finish switching the remaining pumps on. All fuel pumps are running except the engine feed standby pumps, which are in standby, redundancy. In this configuration, the Fuel Control and Monitoring System, FCMS, controls the fuel system automatically. Before you continue, you observe a message on the engine warning display. Click on the forward arrow to display the engine warning display. The message "Refuel in process," displayed in green on the engine warning display, indicates that the refuel control panel door is not set in flight position. We have entered the zero fuel weight center of gravity, the zero fuel weight, and the block fuel in the MCDU for you. As you can see on the ECAM page, the fuel on board, FOB, is 105 tons, 4 tons in the trim tank. A few minutes later, you observe that the refueling message on the engine warning display has disappeared, indicating that refueling is complete and the refuel control panel door is set in flight position. Now that the fuel weight has been entered, you have to verify that the fuel on board quantity on the ECAM fuel page corresponds to the fuel required by your flight plan documentation. Note, the minimum fuel quantity for takeoff is 5,200 kilograms. Also verify the fuel distribution in the different tanks. We have started the APU for you. The green triangle of the ECAM fuel system pages indicates that the APU low pressure valve is open and fuel is fed to the APU. The APU is running using fuel from the engine 1 collector cell, left-hand inner tank. The items related to the fuel system during cockpit preparation are complete. We will now discuss items related to the fuel system that you will encounter during engine start. The indications and starting procedures are the same for both engines. Normally, during engine start, the ECAM engine page will be automatically displayed. For training purposes only, to better illustrate what occurs in the fuel system, the ECAM fuel page will be presented. Select the ECAM fuel page on the ECAM control panel. Before we start the engine, observe the following. The engine low pressure valves are crossline amber to indicate closure. The fuel used quantities remain from the previous flight. Engine identification numbers are amber. This is because the engines are not running. Engine 1 has been started. Observe, the engine low pressure valve is open, inline green. The fuel used indication automatically resets to 0 and begins to calculate the new engine fuel used. Engine identification number 1 changes to white. Click on the forward arrow to continue. The second engine has been started for you. The engines are fed by their engine feed pumps using fuel from the associated collector cells. The APU can now be stopped. Click on the forward arrow to shut down the APU. The APU is shut down. Notice that the APU low pressure valve indication has turned white, indicating that the APU low pressure valve is closed. Fuel is always fed to the engines from the inner tanks. If there is fuel in the center tank is emptied first by transferring fuel to the inner tanks. As you can see on the ECAM fuel system page, both center tank pumps are running, in line green, and the inner tank inlet valves are open. The inner tank inlet valves operate independently and cycle their respective inner tank contents between under full and high level, under full being at approximately 2,000 kilograms below high level. The items related to the engine start are complete. We will now discuss items related to the fuel system that you will encounter in flight. During takeoff and initial climb, the engines are fed from the collector cell using fuel from the inner tanks. When the center tank is empty, the pumps turn off automatically and both inner tank inlet valves close. The trim tank transfer system controls the center of gravity CG of the aircraft. When the aircraft is in cruise, the Fuel Control and Management Computer FCMC calculates the center of gravity and compares the result to a target value which depends on the aircraft's actual weight. From this calculation, the FCMC optimizes the center of gravity position by deciding the quantity of fuel to be transferred to the trim tank, aft transfer, or from the trim tank, forward transfer. This optimization saves fuel by reducing the aircraft drag. If the actual center of gravity is forward of the target center of gravity and the aircraft is above flight level 255, an aft transfer occurs, as indicated by the green arrows on the ECAM fuel page. Fuel for the trim tank aft transfer can be provided also by the center tank unless it is empty. This transfer will automatically stop when the actual center of gravity reaches the target center of gravity minus 0.5%. Note, if during the transfer the inner tanks are out of balance by more than 500 kilograms, the transfer is automatically stopped on the lightest side until the fuel balance is recovered. A forward transfer occurs automatically in order to maintain the actual center of gravity within 0.5% forward of the target center of gravity. A forward transfer is normally directed to the inner tanks and may be directed to the center tank when it is not empty. On the memo display, Trim Tank Transfer appears in green during the trim tank transfer. As soon as one inner tank content reaches 4,000 kilograms, a forward transfer occurs to cycle the fuel in the inner tanks between 4,000 kilograms and 5,000 kilograms until the trim tank is empty. Note, if during the transfer the inner tanks are out of balance by more than 500 kilograms, the transfer is automatically stopped on the heaviest side until the fuel balance is recovered. A continuous forward transfer also occurs when descending through flight level 245, or when time to destination given by the FMGES is less than 35 minutes. If the trim tank forward transfer pump has failed, the transfer occurs when time to destination is less than 75 minutes, gravity transfer. The forward transfer will stop automatically when the landing gear or the slats are extended, whatever occurs first. Note, if an inner tank reaches the high level, the transfer stops to prevent a tank overflow and restarts when the quantity reaches 2,000 kilograms below the high level. The trim tank has been emptied, as shown by the indications on the ECAM fuel system page. The message, Trim Tank Transferred, displayed in green on the ECAM memo. As soon as one inner tank quantity drops below 3,500 kilograms and the trim tank is empty, the outer tank transfer valves open to cycle the inner tank content between 3,500 kilograms and 4,000 kilograms. The outer to inner tanks transfer is performed by gravity. The outer to inner tanks transfer is indicated by, on the ECAM fuel page, the appropriate symbol in either outer tank. On the ECAM memo, the message Outer Tank Transfer displayed in green. The outer tank transfer valves will close automatically when the outer tanks are empty for 5 minutes. The outer tanks are now empty, as shown by the indications on the ECAM fuel system page. The message Outer Tank Transferred is displayed on the ECAM memo. The items related to the fuel system in flight are complete. We will now discuss items related to the fuel system that you will encounter during the post-flight. The first action after landing is to start the APU. Click on the forward arrow to start the APU. The APU is running using fuel from the engine 1 collector cell. Notice the APU low pressure valve indication on the ECAM system display and the APU avail memo on the engine warning display. Click on the forward arrow to continue. The next step is to stop the engines. Click on the forward arrow to stop the engines. As soon as the engine master switch is selected off, the associated low-pressure LP valve closes, crossline amber. Click on the forward arrow to stop the APU. The APU is shut down, indicated by the APU low-pressure valve symbol, which has turned white. Also notice that the GW value and the GWCG value indications have disappeared, if no calculated data is available. This is a demonstration of a failure of the left wing tank pumps. You are in cruise. All the systems are operating normally. Click on the forward arrow to activate the failure. On the engine warning display, read the title of the failure. The ECAM caution left pump 2 low pressure appears amber, meaning that main fuel pump 2 has failed. Note, the master caution and the single chime are not triggered as the standby pump is now automatically running. Redundancy. Notice that the ECAM fuel page is automatically displayed. Notice the corresponding indications. On the ECAM page, low boxed amber means that the pump is on, but not producing adequate pressure. And on the fuel control panel, the fault light is illuminated amber on the left 2 pump push-button switch. Click on the forward arrow to perform the ECAM action. On the left 2 pump push-button switch, the amber fault light disappears and is replaced by the white off light, indicating that the pump has been turned off. On the ECAM fuel page, the low indication disappears and is replaced by an amber cross line, meaning that left fuel pump 2 has been manually switched off. Click on the forward arrow to clear the fuel page. On the status page, left fuel pump 2 appears amber in the inoperative system column. Click on the forward arrow to clear status. You are continuing in cruise. Remember that the left fuel pump 2 has failed. Let's see what happens if left fuel pump 1 also fails. Click on the forward arrow to activate the failure. On the engine warning display, read the title of the failure. The ECAM caution left pump 1 low pressure appears amber, meaning that main fuel pump 1 has failed. Note, the master caution and the single chime are not triggered as the tank has another pump for redundancy. Click on the forward arrow to perform the ECAM action. On the ECAM fuel page, the low indication disappears and is replaced by an amber crossline, meaning that left fuel pump 1 has been manually switched off. The abnormal procedure is complete. The fuel system is analyzed. Click on the forward arrow to clear the fuel page. On the status page, the left fuel pump 1 appears amber in the inoperative system column. Note, with any 2 pumps out of 3 inoperative, the fuel aft transfer is inhibited. Thus the message fuel aft transfer appears amber because left pump 1 and 2 are selected off. Click on the forward arrow to clear the status page. You are continuing in cruise. Remember that the left fuel pump 2 and left fuel pump 1 have failed. Let's see what happens if the left standby pump also fails. Click on the forward arrow to activate the failure. On the engine warning display, read the title of the failure. The ECAM caution left wing pumps low pressure appears amber, meaning that both main fuel pumps and the standby pump have failed on the left side. Once again, the ECAM fuel page is automatically displayed. The left standby pump indications are the same as for left fuel pumps 1 and 2, shown previously. Click on the forward arrow to perform the ECAM action. Observe that the on light illuminates white on the wing crossfeed push-button switch to indicate that the valve starts to open. The crossfeed valve is shown amber during the valve transit, and the open light illuminates green when the valve is fully open. On the ECAM page, the crossfeed valve is inline green. This allows both engines to be fed from the right-hand wing tanks. Note, the wing crossfeed valve opens automatically in case of emergency configuration. Click on the forward arrow to continue the ECAM action. The left standby fuel pump indications are the same as for left fuel pumps 1 and 2 shown previously. The fuel in the left tanks is only available using gravity feeding. When gravity feed from the left tank is required, for example to avoid exceeding fuel imbalance limits, apply the gravity feeding procedure contained in the QRH. Click on the forward arrow to clear the fuel page. All the left tank pumps are inoperative. This is indicated in amber. The aft transfer is still inhibited. Note, at this time, the right tank pumps are still feeding the engines. When fuel from the left tank is required, refer to your documentation for gravity fuel feeding. Click on the forward arrow to clear the status page. ECAM action completed. We learned from the ECAM actions and indications associated with the left tank pump failures that losing 1 or 2 inner tank pumps is not so critical. No master caution, because of redundancy. 3 pumps. Losing the 3 inner tank pumps means opening the wing crossfeed valve for feeding both engines from one side. Using gravity fuel feeding if necessary. Refer to your documentation. This is a demonstration of a failure of the center tank pumps. You are in cruise, all the systems are operating normally. Click on the forward arrow to activate the failure. On the engine warning display, read the title of the failure. The ECAM caution, left center pump low pressure, appears amber, meaning that the left center pump has failed. Notice that the ECAM fuel page is automatically called. Notice the corresponding indications. On the ECAM page, low boxed amber means the pump is on but not producing adequate pressure. And on the fuel control panel, the fault light is illuminated amber on the left center tank push-button switch. Note, the fuel transfer is still operating normally, as only one pump is inoperative. Click on the forward arrow to perform the ECAM action. On the left center tank pump push-button switch, the amber fault light disappears and is replaced by the white off light, indicating that the pump has been turned off. Click on the forward arrow to clear the fuel page. On the status page, the left center pump appears amber in the inoperative systems column. Click on the forward arrow to clear the status page. ECAM action completed. You are continuing in cruise. Remember that the left center tank pump has failed. Let's see what happens if the right-hand center pump also fails. Click on the forward arrow to activate the failure. On the engine warning display, read the title of the failure. The ECAM caution, left plus right center pumps low pressure, appears amber meaning that both center pumps have failed. Notice that the ECAM fuel page is automatically called. As both center tank pumps are inoperative, the center to inner tank fuel transfer is affected. Thus, the two center to inner tank transfer valves are displayed in amber. Due to the center tank pump's failure, part of the center tank fuel is now unusable, 15 tons. Thus, the fuel quantity indications corresponding to the fob and the center tank are boxed amber. Click on the forward arrow to perform the ECAM action. As both center tank pumps have failed, the fuel transfer from center to inner is stopped. The two amber arrows have disappeared. The engines are fed using fuel from the inner tanks only, until either inner tank reaches 17 tons. Click on the forward arrow to clear the fuel page. On the status page, the center tank pumps appear amber in the inoperative system column. As both center pumps are inoperative, the aft fuel transfer is inhibited. Click on the forward arrow to clear the status page. You are continuing in cruise. Remember that both center tank pumps have failed. Let's see what happens when either inner tank quantity drops below 17 tons. Click on the forward arrow to continue the procedure. On the engine warning display, notice the recall of the failure. Once again, the ECAM fuel page is automatically called. Notice the amber fault light on the center tank transfer push-button switch. Click on the forward arrow to perform the ECAM action. On the fuel panel, the amber fault light disappears on the center tank transfer push-button switch and is replaced by the white manual light. Fuel is now transferring from the center tank to the inner tanks by gravity. With a gravity transfer, 15 tons of fuel in the center tank will be unusable. On the ECAM fuel page, both transfer valves are now displayed filled green, as the center tank transfer push-button switch is set to manual. The abnormal procedure is complete. The fuel system is analyzed. Click on the forward arrow to clear the fuel page. On the status page, the indications are the same as those shown previously. Click on the forward arrow to clear the status page. This is a demonstration of a failure of a fuel transfer from the center tank to the inner tanks. You are in cruise. All the systems are operating normally. Click on the forward arrow to activate the failure. On the engine warning display, read the title of the failure. The ECAM caution, center to inner fault, appears amber, meaning that the center to inner transfer has failed. Notice that the ECAM fuel page is automatically called. Automatic center transfer failure is depicted by the two amber arrows on the ECAM fuel page. Notice that the transfer failure also causes both center tank transfer pumps' fault lights to illuminate. Click on the forward arrow to perform the ECAM action. As both center tank pumps have failed, the fuel transfer from center to inner is stopped. The two amber arrows have disappeared. The engines are fed using fuel from the inner tanks only, until either inner tank reaches 17 tons. Click on the forward arrow to clear the fuel page. On the status page, a green memo indicates that only manual center transfer is available. The other indications are identical to those previously shown. Click on the forward arrow to clear the status page. You are continuing in cruise. Remember that both center tank pumps have failed. Let's see what happens when either inner tank quantity drops below 17 tons. Click on the forward arrow to continue the procedure. On the engine warning display, notice the recall of the failure. Once again, the ECAM fuel page is automatically called. Notice the amber fault light on the center tank transfer push-button switch. Click on the forward arrow to perform the ECAM action. On the fuel panel, the amber fault light disappears on the center tank transfer push-button switch and is replaced by the white manual light. On the ECAM fuel page, both transfer valves are now displayed filled green as the center tank transfer push-button switch is set to manual. Click on the forward arrow to continue the ECAM actions. We have switched both center tank pumps on for you, as the procedure is identical for both push buttons. Notice the corresponding indications on the ECAM fuel page. Fuel transfer from center tank to inner tanks will continue until the center tank is empty. You will have to set the center tank transfer push-button switch back to auto when the center tank is empty. The abnormal procedure is complete. The fuel system is analyzed. Click on the forward arrow to clear the fuel page. On the status page, the memo reminds you that the center to inner tank transfer is in manual mode. Click on the forward arrow to clear the status page. ECAM action completed. We learned from the ECAM actions and indications associated with the center to inner fuel transfer failure that automatic fuel transfer is lost. Both center tank pumps have to be set to off. Manual transfer is available by selecting the center tank transfer push-button switch manual when either inner tank's quantity drops below 17 tons. Both center tank pumps have to be set back to on when the manual transfer is initiated. Let us now finish this module with an abnormal forward transfer situation. Following a trim tank transfer failure, you have performed a forward manual transfer from the trim to the center tank. Note that on the A330-200, it is not possible to perform a manual forward transfer from the trim to the inner tanks. This is a demonstration of a failure of an automatic forward transfer. You are in cruise, all the systems are operating normally. Click on the forward arrow to activate the failure. On the engine warning display, read the title of the failure. The ECAM caution Trim Tank Transfer Fault appears amber, meaning that the automatic forward transfer has failed. Notice that the ECAM fuel page is automatically displayed. Notice the corresponding indications. On the ECAM page, the left and right forward transfer arrows are displayed amber, and on the fuel control panel, the fault light is illuminated amber on the trim tank mode push-button switch. Click on the forward arrow to perform the ECAM action. On the fuel panel, Trim Tank Mode push-button switch, the amber fault light disappears and is replaced by the white forward light, meaning that a manual forward transfer has been selected. After having selected manually the forward transfer through the fuel panel, the left and right forward transfer amber arrows disappear and are replaced by an arrow from the trim to the center tank. This arrow is displayed filled green, indicating that a manual forward transfer is in progress. The fuel system is analyzed. Click on the forward arrow to clear the fuel page. On the engine warning display, the memo Trim Tank Transfer is displayed green, meaning that a trim tank forward transfer is in progress. ECAM action completed. You are still in cruise. The trim tank is now empty. Click on the forward arrow to continue the procedure. On the engine warning display, read the title of the failure. Notice that the ECAM fuel page is called automatically when the trim tank is empty. On the ECAM fuel page, the trim tank valve closes automatically when the trim tank is empty. Click on the forward arrow to perform the ECAM action. On the Trim Tank Mode push-button switch, the forward white light extinguishes, meaning that the trim transfer is set to automatic mode again. On the ECAM fuel page, the indications related to the forward transfer have disappeared. Click on the forward arrow to clear the fuel page. On the engine warning display, the memo Trim Tank Transferred is displayed green, meaning that the forward transfer is completed. ECAM action completed. We learned from the ECAM actions and indications associated with the automatic forward fuel transfer failure that fuel transfer from the trim tank to the center tank can be manually selected through the Trim Tank Mode push-button switch. When the trim tank is empty, the failure is recalled and the Trim Tank Mode push-button switch has to be selected back to auto. In some cases, you will have to use the trim tank feed selector either to completely isolate the trim tank or to manually force the forward transfer. You are still in cruise. All systems are restored and operating normally. We are now going to study the failure of the fuel transfer from the outer to the inner tanks. Click on the forward arrow to activate the failure. On the engine warning display, read the title of the failure. The ECAM caution outer to inner fault appears amber, meaning that automatic transfer from outer tanks to inner tanks has failed. Notice that the ECAM fuel page is automatically called. Notice the corresponding indications. On the ECAM fuel page, the outer tank transfer indication turns from a hollow green arrow to a plain amber one, meaning that the left outer to inner tank transfer has failed. And on the fuel control panel, the fault light is illuminated amber on the outer tank transfer push-button switch. Click on the forward arrow to perform the ECAM action. On the outer tank transfer push-button switch, the amber fault light disappears and is replaced by the white on light, meaning that the outer to inner transfer valves are controlled open. Note, the outer tank transfer push-button switch controls both transfer valves simultaneously. On the ECAM fuel page, the outer to inner transfer valves appear in full green, indicating that a manual transfer has been selected. The fuel system is analyzed. Click on the forward arrow to clear the fuel page. On the engine warning display, the memo Outer Tank Transfer appears green, as a transfer from the outer to the inner tanks is in progress. ECAM action completed. You are still in cruise. The outer tanks are now empty, shown by the ECAM memo message, Outer Tank Transferred, displayed in green. Click on the forward arrow to continue the procedure. On the engine warning display, read the title of the failure. The ECAM caution, Manual Transfer Completed, appears amber, meaning that the manual outer to inner tanks transfer is completed. The ECAM fuel page is automatically called. You can notice that the outer tanks are empty. Click on the forward arrow to perform the ECAM action. On the fuel control panel, the outer tank transfer push-button switch extinguishes, meaning that the manual transfer has been stopped. On the ECAM fuel page, the green arrows in the outer tanks have disappeared, indicating that the transfer valves are closed. The abnormal procedure is complete. The fuel system is analyzed. Click on the forward arrow to clear the fuel page. ECAM action completed. We learned from the ECAM actions and indications associated with the outer to inner tanks fuel transfer failure that fuel transfer from inner to outer tanks can be manually selected through the outer tank transfer push-button switch. When the outer tank transfer push-button switch is selected on, both transfer valves are controlled open until the outer tank transfer push-button switch is set to auto. You are in flight just after takeoff, when an emergency suddenly occurs which requires you to land as soon as possible. A jettison operation must be carried out, since the aircraft weight exceeds the maximum landing weight. On the MCDU Fuel Pred page, a jettison gross weight has to be inserted. Click on the forward arrow to insert it. The jettison gross weight is now inserted in the MCDU. To start the jettison operation, you will have to arm and then to activate the corresponding push-button switches. Click on the forward arrow to arm and activate the jettison. Observe that on the ECAM fuel page, the jettison valves open as shown by the corresponding indications, with the green open light on the panel when the valves are fully open and the jettison memo on the engine warning display. Notice also that the standby fuel pumps automatically start to operate, and the crossfeed valves automatically open, with the corresponding memo on the engine warning display. Fuel is jettisoned simultaneously from the center tank using the center tank pumps, and from the inner tanks using all fuel pumps. Click on the forward arrow to jettison the remaining fuel and observe what happens on the ECAM fuel page. As the gross weight reaches the predicted value pre-selected in the FMGES, the jettison normally stops automatically, but a failure has been detected. On the engine warning display, read the title of the failure. The ECAM caution, jettison not closed, appears amber, meaning that the jettison valve is jammed open. On the ECAM fuel page, the corresponding jettison indication and the arrow are displayed in amber. On the fuel panel, the fault lights are illuminated on the center tank push-button switch. Click on the forward arrow to perform ECAM action. As you can read on the engine warning display, if the jettison is confirmed, you will have to switch off the center tank pumps. In case of gravity transfer from the center to the inner tanks, 15 tons of fuel remain unusable. Therefore, the 500 kilograms in the center tank are lost. We will stop the exercise here. Now let's see some abnormal indications that you can have on the ECAM fuel page. On the engine warning display, the FOB indication is displayed with 2 amber dashes across the 2 last digits in case of degraded accuracy. Click on the forward arrow to select the ECAM fuel page on the ECP to determine which tank is affected. You can see that the affected tank is the left outer tank. The 2 amber dashes indicate a loss of accuracy of the indicated fuel quantity.